All right, hello, my name is Olivia Thomas. Today I'm going to be talking about human-centered design, primarily in a practical sense based on my experience with the software engineering process, and at a lower level than we typically talk about it. I'm going to be talking about how the nature of the code that we write interacts with this idea of making human-friendly software. Just to quickly introduce myself, I work in tech. My background is in computer science, and I am currently a product manager on Microsoft Excel, and also a master's student at the University of Edinburgh. But more pertinent to this discussion is the different roles that I've had in software development. I've worked on quite a few different teams and projects, both at Microsoft and prior to that, and either by title or necessity, I've had experience doing a lot of different things on these projects. And I've gotten to see the process from a lot of different angles. So that's a big part of what I want to talk about today. Okay, first, I just want to talk about how scary computers are. I think any of us can relate to this picture at one time or another, and maybe especially those of us who create software professionally. Digital technology does great things for us. It's super powerful, but it also causes frustration. And this kind of sense of frustration, I think, is almost ubiquitous among the people who use it at times. There's this sense among many of us that it's not fundamentally compatible with us as humans. And as much as it helps us, it's kind of also working against us in a way. So why is this? In the case pictured here, we have a bunch of error messages that are not very helpful, which is a pretty common experience. And my first impulse when I see these is to say, well, this is a case of bad design. And it's true, there's a lot we could do to improve the design here. Specifically, the writing of these error messages, they're not very helpful, they're not very specific, they don't tell us what's wrong. And fixing that would certainly decrease friction of the experience and hopefully the frustration. This kind of thinking leads to the perception that good design automatically leads to a usable product. Maybe there's some iteration and some back and forth required to get a good design, but as long as the design is good, as long as we get there, we'll end up with a good product. And if the product doesn't turn out well, then either the design was bad or the developers basically, weren't doing a good job and didn't follow it. However, the reality is a lot more complex than this. So let's step back a little bit. We've been talking about design. What do we mean by design in the context of software engineering? To answer that question, I looked up some job postings for designers in tech who often have titles like UX designer or UI designer. And you can see some bullet points that I pulled out from those job postings here. We get the sense that design is primarily about creating concepts. These concepts are for the visual appearance of the user interface or the UI, and the behavior of how the interface responds to the interaction or the user experience, reflected by words like wireframes, user interactions, software requirements, maybe even prototypes that designers work on. So design is primarily about what users see and experience in the application. There's a mention of working with developers. Engineering may put constraints on the design and designers may collaborate with engineers, but engineering is still kind of left off as a different realm. Design is concerned with the experience, not the code. Okay, so how does design become reality? To understand that, we need to talk about the nature of digital software. I really like David Brooks's exploration of this in his paper, No Silver Bullet, where he talks about the 4 essential difficulties of software development. So let's start there. The first difficulty is complexity. Software has a huge number of possible states, making it difficult to enumerate or even understand all possible states of a program. Anyone who's done programming has definitely experienced this. It's just one of the most complex systems that humans have created. And as much as we try to understand all the possible states that it can be in, that's an extreme kind of essential difficulty of software engineering. The second difficulty is conformity. Software may be complex, but at least it's logical and structured. Human systems, on the other hand, often have arbitrary complexities that software must conform to, which further increases the overall complexity of these software systems that we create. Date formats are a great example of this. They're different all over the world. And so software systems can't just have kind of a standardized date format, but they need to be able to adapt to all these different arbitrary human conventions. Next, we have changeability. Unlike building a bridge, which you expect to not continue working on after it's built, hopefully, software can be easily changed. So it does change, and then it in turn requires change from other software that depends on it. So it's kind of in this constant state of development and flux, especially in the age of the internet, where we can deploy new versions of software very easily. Finally, software is not inherently spatial. There have been plenty of attempts to visualize software over the years, like UML and data flow diagrams, but these usually only show one or two dimensions of the system, not the whole reality of the system. So there's always kind of this level of not being able to visualize the things that we're talking about. So in response to these challenges, the software industry has moved towards iterative and incremental development. Instead of making all the plans at the beginning, we think of software as something that is grown. We build up the functionality and the design little by little, testing and iterating as we go. And this is really good practice for creating software, but it's not uncommon for teams to do this right and still end up with suboptimal user experiences. Why is this? Well, things that grow make up an ecosystem. So does software. There are many levels to the software ecosystem, including conventions within a single project, the external code used by the project, and even the programming languages and the hardware that it runs on. And the thing about ecosystems is that the components within them are interdependent. Any change you make to an ecosystem compounds. You plant one tree and it's going to multiply. Introduce one invasive species and it can change everything. Similarly, one small change at any level of a software project can have huge effects. And as that software project grows, the more embedded something becomes in an ecosystem, the more time and money it takes to change, to the point where some things just become untenable to change at all without remaking the whole thing or large portions of it. Let's look at some examples of this. Imagine that we are creating a journaling app, kind of an app where the user is adding their own content to the application. And this app has different kinds of things that the user can put in their journal, like text, images, and maybe formatting. They can change the colors, they can highlight things, whatever kind of objects they might want to add. Any good designer or product manager is going to identify that the user should be able to undo anything they've added, right? Sometimes we don't intend, once we see something, we're like, no, that's not what I want, not what I intended, so I want to undo it. It's a pretty bad experience that the user can add things in this context, but they aren't able to undo them. Okay, so now we're developing the app, and we have a couple options about how to implement this, which I've written out here in Java code. We're going to create a journal object, which represents something that the user can add to their journal. And then we'll be able to basically create different kinds of this journal object to represent text and images and whatever the different types of objects are. Now, the choice here is that I can make the journal object either an interface or a class. This seems like squarely an engineering decision, right? Not something we would expect a designer to weigh in on. And from a software engineering perspective, there are plenty of valid reasons why I might choose either of them. And in both cases, I can make insertion undoable, so it's going to satisfy the design. So let's say I choose option 2. Believe it or not, I've just made a profound design decision that will reverberate throughout the ecosystem and most likely degrade the user experience. The reason for this is that with an interface, the first option, all functions are required to be implemented. So any developer in the future who comes in to add a new journal object is going to be required to make it undoable, or their code just won't compile. They won't be able to add it to the project. But when I make a new version of option 2, the class, I can override the empty undo function and add undo functionality, but I don't have to. There is now a design value embedded in this ecosystem that not everything has to be undoable. And sure, at first, like, since we're really concerned about undo with this particular set of features that I'm working on, I'm probably going to implement undo. But it's now something that kind of doesn't happen automatically. It's something that, or it's not something that's guaranteed to get implemented, but there's a chance it's going to fall through the cracks in the future. And this problem may compound under the radar until we have dozens of journal objects that users can add but not undo. And by the time design catches on, it may take a huge months-long effort to go back and add undo to all of these journal objects, much longer than it would have taken to do so along the way. This effort will sap engineering resources that could have been used for other parts of the product, and most likely cuts will have to be made to other parts of the design. If this sounds too bad to be true, I assure you I've seen very similar things to this happen with very competent development teams. And it's not a cut and dry case of bad design or bad engineering as we define those things today. It's just that we don't classify or evaluate these kinds of things as design decisions when they have real design impact. The bad error dialogues that we talked about earlier are another example. Often the reason for these is that new error cases are found during development. These cases may be specific to the software ecosystem, and thus they may not have even been possible to anticipate during the design stage. And the structure of the ecosystem determines how much we can know about what caused the error. But the structure of the ecosystem usually wasn't designed with the user experience in mind. As a product manager, I've been in plenty of situations where we run into an error that, new error that's emerged. We probably didn't plan for it early on in the design process. And we can't get more specific than something bad happened in our error message because that's, kind of structurally embedded in the software architecture that we can't know more than that. And it's so embedded in the ecosystem that it's just untenable to make it better without sacrificing a lot of other work that we can't afford to. The ecosystem, of course, goes deeper than the specific application. Even the design of programming languages can trickle down and affect the user experience. For example, functional and object-oriented programming languages are very different from each other. They're both quite powerful and can technically do all the same things. Of course, they're much more powerful than any specific implementation. So it's not as easy as saying like one of them is, produces better designs than the other. But they do lend themselves more easily to certain things than they do to others. And just like the previous examples, this can affect user experience. Even at the hardware level, the fact that most computers use binary logic also has a profound impact on the ecosystem. And it doesn't necessarily have to be that way. Ternary computers have been created. We have quantum computers, of course, as well, which may become more ubiquitous in the future. So when we talked about design initially, we said it's about what users see and experience in the application. What we've seen through these examples is that coding level decisions, which are typically not considered design decisions, can have profound effects on the user experience of the final product. So when it comes to software engineering, everything is design. Design goes down to the byte level. It's not just a conceptual blueprint or a surface that we put on top of code like brushstrokes. It's every line of code. It's the syntax of programming languages and even the hardware on which those programs run. But these lower level components of design rarely get the same amount of attention as the visual surfaces they enable. A big obstacle to this is that the conceptual models used by developers and designers are so vastly different. The field of design is good for thinking about what the surface should be, but doesn't have a good language for engaging with software architecture. UI designers sort of do because there's often a shared library of user interface components that both developers and UI designers work with. But when it comes to the more invisible parts of the design, like interaction, there's often really not such a shared language that they have. On the other hand, software engineers are typically trained to think and make code decisions based on logic and efficiency, not end user experience considerations. So even when designers and developers work together iteratively on a project, it's not uncommon for a software system to diverge fundamentally from the design. So what do we do about this? First and foremost, I think we need a shared language between designers and developers that allows for dialogue about all levels of design, not just the top level. Some things that may help with this are design tools that are more integrated with programming languages created with design principles in mind, and also educating programmers and designers together instead of in disconnected departments and programs. I am not advocating for more top-down control of projects by designers or anyone else. Thinking about design top-down is really the core of the problem here. Rather, I'm envisioning a world where everyone on a software development team actively and knowingly participates in design from the byte level up, and where we have the shared metaphors, conceptual frameworks, and tools that enable this. As a final note, I'd be remiss if I didn't talk about generative AI in this year where it's become such a big and powerful thing. Large language models do a really good job of translating natural language to code. So do they solve this problem? They're a new element of the software ecosystem and a powerful one. But any part of the code that they write is still subject to all of the inherent design values of the ecosystem that it's a part of. And they're currently good at creating code snippets, but not architecting an entire project. So there's still a lot of human thinking that's needed for prompting, just as there is for programming. That said, they can be a really great tool. And if we use them and build upon them in intentional ways, I think they can help us get to a world where code is easier to talk about, which is exactly what we need. And with that, I'd like to open it up for discussion.
Olivia, thank you very much. Can you hear me?
Yes, I can hear you.
This is really interesting. So what fascinates me the most about so much of what you said, and there's a lot to talk about, is how you emphasize the design choices made at the programming level, and also how, as you say, the very grammar or syntax of the programming language and the choices you make at the ground level up have ramified implications for the design experience. And so this leads me to sort of two thoughts, and I'd like to ask your opinion about them. One is that we can't disassociate what I call the cybernetic grammar of computers from the graphical user interface or the design of digital technologies and media. That, as you're emphasizing, the programming choices or the coding choices you make have these implications that cascade down throughout the user experience. And this means then that the fundamental way that we on the one hand design our digital technologies to automatically script their programming or to generate that programming. On the other hand, the fundamental constitution of our computers, whether they be, I'd say, binary, ternary, quantum computers, all of those things have, they're like the alphabet that sort of is embedded in our language and our whole sort of discursive culture. And then the other thought that I had was, and this is, I think, is where my question comes from, is it possible to have a kind of visualization, a sort of design level view visualization of the programming that would provide a kind of shared vocabulary for both the programmers and the designers? So what I've been learning about recently is a famous Catalan mystic named Raymond Lull, who in the 13th century, he conceived of a kind of diagrammatic visualization of a kind of a mnemonic computer by which he thought he could calculate certain judgments. And this is obviously a medieval example, it's not a modern example. What I wonder is whether the programming language could be visualized in such a way that would allow for the designers to understand what the consequences of certain programming choices will be, and then also to anticipate how they work with programmers to produce certain design outcomes.
Yeah, that's a great question. And certainly having that kind of visualization would help a lot. I think, when I program, that's like, I have to visualize things. It gets too complicated to think about everything, and kind of to figure out my own logic and figure out my own assumptions, I just have to take out a pen and paper and write things down. The inherent difficulty with that is kind of what we talked about with Brooks. One of the fundamental difficulties of software engineering is that it is not inherently embedded in space. And so far, I'm not familiar with the visualization that you talked about. I'm really curious about that. So far, most ways of visualizing software usually only kind of address one or two axes of the reality. and not the whole picture. So there's a difficulty with visualizations, and I don't think it's yet been done in a way that's perfect. But I think also, trying to figure out on a more abstract level the conceptual framework, like the touch points conceptually between code and design concepts, and then starting to diagram those once we have it like sliced better, may eventually help us get to that point.
Are there any further questions? Did you have?
Yeah, I just had a kind of a wondering, I guess, what kind of products would be created from a design influenced programming language? Like how do you imagine the outcomes of those being different? And what are some of the qualities and principles of those products or even that programming language?
Yeah, I mean, I think there's a lot of work that would need to be done to kind of enumerate like what are the values we would want to put into that programming language. And it could be quite a bit different depending on how it's designed, right? I think, a really concrete example that I can think of is accessibility. Accessibility is a thing that, in the industry we really push for. Things should be accessible for people who have low vision or low hearing, and there's still so much friction in implementing that, even though we kind of all agree that it should be a thing, because those like the alt text, for example, or like screen reader capabilities are usually like stuff that has to be added on, and there's usually like it's not built into components. There's usually quite a bit of hassle in actually getting things to work with these things. So like that's one concrete example I can think of, is just like bottom up, making the programming language like require alt text, making it a smooth experience to have alt text, really like putting focus on that integration of alt text everywhere being seamless, would be one example.
Cool. I'm also curious, as a product designer too, I'm curious what you think a product team might look like that smoothly integrates, I guess, design principles into this development process. I, for one, I think often am on teams where it's just handoff, like you hand off designs and then they figure it out, and then you see it and you do like QA and just like a review. But I'm wondering if you see more like lockstep, like co-working or teams like of different sizes.
Yeah, talking about the handoffs, I think inherently like there's a lot of problems with just thinking of design as something that you create and then hand off, because as we said, software is something that grows, it iterates. As implementation happens, developers learn things that maybe mean they can't totally match the design, or there's new things that they could do that they didn't realize they could do. Like the best software actually happens when you keep the design flexible. So I think just like collaboration through all the stages of the process is really important. Like considering the design not done until the very end of the project. Something that I think is also really helpful is kind of designing in stages instead of designing the entire thing at once. There's a diagram on the internet that I really like, where it's like you should build software instead of like, if you're building a car, instead of starting with the wheels and then adding all these different components one by one and eventually getting to a car, you should start with like a scooter and then get to like a moving platform. Like every version of the software should be functional on its own so you can test it. And so I think thinking like that, like having designers first design a V1 that's like simple to create, then the developers create it, then testing it with users and seeing how they respond to it, and then kind of iterating on the design based on that feedback and doing it over and over again is really good practice.
Awesome. Thank you.
Thank you,
Yeah.
Olivia.